one of those programming course earlier, this was one of the questions that probably you got 2 marks in an exam or CET. Oh yes, someone here wants to say something. Yes, yes, yes. The one who's raised the hand, say something.
I found the okay, both a compiler and an interpreter are translators,
Okay.
which converts a program into high level language, from level language into object language, machine language, and
Okay.
then a compiler
Okay.
translates an entire program,
Okay.
while an interpreter translates like one single line at a time.
Okay. 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 Fair. I agree with that. I agree with that. I hope you can hear me. Um. So yes, also here Edmond says something. Uh, if you can try and copy paste it to everyone, I see you sent the message privately, so that at least we can have that discussion before we get started. So assembler, assembly language to machine code, okay, and you give an example there, okay. Compiler, source program written in high level to machine code, okay, and then interpreter, high level to machine code line. For instance, you're talking about Python, okay. I agree with that. I agree with that. I agree with that. I don't know whether there's anyone else with different views or a different way that they are looking at it. Okay? The reason why I'm asking this question is because we need to understand what this thing is doing, right? I remember last time I gave a general overview, and I have actually come up with a very nice flow chart that I'm going to share in a short while as soon as I'm done with a short course overview here that will help you understand what the compiler will be doing, right? You'll also see a difference between that and interpreter and translators. I may not give the exact distinctions, right? Because this is not the place to start discussing them again. I'm quite sure you've already come across them and understood them. But for me, in this case, I want you to see what the compiler is doing. Okay? I want you to appreciate what the compiler does, because the main point here is to understand that we as human beings, right, use a different language. It's, for example, English, right? It's optimized for us to understand it that way, even the way it's structured, right? But the computers, on the other hand, and the machines don't see things the same way, right? They are looking at it in terms of zeros and ones, what we are calling the low-level language, right? So we need to move from here all the way down here. Now, compiler is not the one that does all this alone, right? There are other software modules that are going to be involved. Okay, the likes of assembler. I saw someone talk about an assembler there. What else? Preprocessors. What else is there? Other modules. We'll see them in a short while. So the compiler is just one item that does that. Okay, but now the compiler does several activities in there, right, that are very important for us to understand them, because once we understand them, you can even change your own programming style. Okay, each and everyone has a programming style. I remember I mentioned that we can look at programmers in terms of like two different types or two different groups, right? They are good programmers who, when you give them something, a test in programming, what they do is they'll go and search for the results, or they'll go and search for the problem and then try and bring things together, right? Different codes together. Then there are very confident programmers who, on the other hand, will see a problem and then they'll analyze it and understand it. Once you understand what the compiler does, right, it's like a form of reverse engineering, right? You'll get to see a problem in a different way. Once you're given something, you break down the problem into the different variables that you need, into maybe different elements, into tokens. I know you've heard of words like tokens. And in that in mind, you'll have an easier time coming up with whatever code you want to do, you want to write. Anyway, let me just delete this. Okay. So maybe just to repeat what I said last time, in case you are not here, I can see we have a bigger number today. Um, it's good to mention some of these things, right? So we are going to face both theory and practicals, okay? But it's very important for me to mention that this is not a programming class. And the reason why I'm saying that is because if I say this is a programming class, you remember what I said, people will start bookmarking, Stack Overflow and all those, right? So you need to understand the theory behind compilers, and then using that, you're able to apply it to any programming skills that you're going to use. Okay? So for that, you'll find that we'll engage with some different languages. I'm yet to decide on what we are going to use in terms of programming, because I had detailed a very nice project, but then after the concern that was raised by you guys based on the amount of work you have currently as 4 years, I sympathized with you guys, and I remembered I also faced the same problem during my final years. So I'm thinking of finding an easier way of doing the practicals, okay, in a way that doesn't overwhelm you. Okay? So just allow me a couple of weeks just to see what is more convenient for you, because we'll probably start the programming class maybe the third class, okay? After at least we've gotten enough theoretical basis. Okay? So you may choose to use C++, but I'm thinking going for C. I'm seeing like C is an easier option, because what I had before was something that was a certain programming language called Cool. I don't know that you've met it. Okay? It's kind of like a mashed up uh, way of developing codes using Java-like language. Okay, but then that one would have required you to go and start reading manuals and all that. And there's no need to go through that. Okay? Why this course? Why this course? We need to understand compilers and languages. Okay, we need to improve this. This is very important. Programming experience, right? You need to start looking at programming in a different light. Okay, forget that idea of looking at a problem and then quickly you just dash somewhere to get a quick answer. See the problem, analyze the problem, and get to understand what is being asked. Okay. So with that, I remember I asked you to go and brush through your programming skills. So some of these, because we'll apply them depending on which one we decide to use as a group, right? What else? What else? What else do I have in terms of the course overview? I don't think I have anything else. The next is just talking about compilers, and I think we can start here, right? So we are looking at a way of translating information from one representation to another, right? So look at something like this. I know, I'll come back here later on, but look at something like this. This is a simple C program, right? Very simple. Even if you don't remember how to code using C, right, or any other programming languages there, you can tell that you can understand some things over here, right? You can see that there are some variables being declared somewhere, right? You can see there's a form of the parentheses, and then you can see there's a form of like a function that is being started and being initiated somewhere there, right? But then if I was to ask you to try and interpret the same using this, right, which is now in assembly form, you may have a challenge, because here you can see even some registers have been mentioned. Okay, there are so much that is going on, because here the computer is trying to understand even memory locations of where it's going to place those variables. Okay, it's trying to understand where it's going to place them, how it's going to place them, the order, and all that. Right. So when we talk about the compiler, right, just try and reference to that, right, where you're looking at a language, one language that is optimized for a certain user, in this case, us as human beings, right? So it's optimized in our own grammar, right? Our own grammar, probably something like English or any other language that human beings will speak, right? And then we are translating it, okay, to a different language that now, in this case, is that of the machines. So with that analogy in mind, you can actually think of simple translators that translate from one language to another, something like Swahili to English as a simple compiler. Okay, you can somehow label them as that based on that analogy, because they are translating from one type of a language to another. Now I put them in quotes because we'll have a different definition within this context of compiler design or compiler construction. Okay, but then using that analogy of we are translating information from one representation to another, right, you can see why someone would not be wrong to make this conclusion, right? So I'm using this tool to move from Swahili to English. I'm using this tool to move from maybe Arabic to another, something else. Okay? However, like I'm saying, in this case, we are going to look at the context of programming, right? So programming, that is what we are going to have an emphasis. So in this case, the type of compilers we're going to talk about are things like GCC, right? What else? I think there's Turbo, C++, something like that, right? All those are examples. Now, you'll also find there are other tools or softwares out there that are able to convert content from one form to another. Okay? Some other people also will try and interpret those as compilers. Okay? However, in this context, we are going to look at those ones as translators. Okay, and this is the only time I think I'm going to mention things. For instance, think of something that converts a Word file to PDF. Okay? I think you can even see the word translator coming up there. Okay? Now, there's this, which I asked, what is an interpreter? And I think I'm also going to ask it again. Oh, I see someone had written an answer here. Vivian, I think I didn't see it. So an interpreter does not generate intermediary code, but a compiler generates intermediary. Yes, that is one of the distinctions, right? Okay, actually one of the levels that you're going to see, the flowchart which I'm about just to share right now, you'll see that a segment or a section of the compiler, when it's doing its thing, there is something that we call intermediate representation, where an intermediate code is generated, right, to be used in the back end, because we are going to split the compiler into different passes for one reason or another, right? So yes, so an interpreter does not do that, right? Anyway, I challenge you to go and check those differences. Okay, I may not we may not examine them here because they're not important to us, but it's always good to always remember some of these things. So ours in this case, and I need to really emphasize on that, is to understand that we are moving from information represented in one form, okay, to another low level language. If you understand that, at least you have some basis, okay, of where to start. Okay, and maybe I can share something over here, a flowchart that can give a better perspective into what I'm saying. Just give me a second. Here, good. Okay, look at this. Is there a question? I saw a raised hand. I think it was from the past when someone had asked a question. Okay. Um, good. So look at this. And let me start from here. Let me take my Antonita for a second. Let me just split this into two. That way. Okay. So so we have our high level language. Okay, something like the one that you're used to, Java, whatever it is, whichever, right? You have them up here, high level language. So our aim is to go to an executable code, in this case, zeros, ones, okay, all that. Okay? That is what we are aiming to do. Okay? And I remember I did highlight some of these stages. I don't know whether anyone can remember. What was the preprocessor doing? I remember I just mentioned it in passing. So if you don't remember or you can't recall it, okay, I'll repeat. But I'm just trying to see whether there's someone who has maybe their own interpretation of what the preprocessor was doing. Okay? I tend to find when a peer or a fellow student is able to highlight their own understanding, it becomes easier to comprehend something. Okay? Me, because probably I've interacted with some of these things for a while, I may assume something. So going once, I don't see anyone saying something. But anyway, so when you write your programs, right, in the high level language domain, right, you always include things like the hash include, right? Hash include. Bear with me. I'm trying to write using a mouse. I don't have a stylus pen. But anyway. So include. Okay, you have things like hash include. You have things like hash define. Okay? So maybe there are certain variables that are changing, and you don't want to keep on changing them all the time within the code, right? You want to declare them somewhere, and then over time, depending on how they change, you just come and change them at one point, and then they're updated everywhere within the program, right? So, for instance, something like what maybe you have a levy, a custom. Okay, maybe you're writing a program that is able to calculate the amount of money that you're going to pay for a vehicle once you import it from outside the country. Unfortunately, we don't manufacture our own vehicles. So at the customs, right, down there in Mombasa, they are going to calculate for you some levy charges. So many of them. I don't understand. That's something I don't understand. Anyway, so maybe you bought your car. Let's say you bought it at $5,000, right? So when it gets there, you're told there's this levy that changes, right? So it varies depending on the type of car, maybe the year it was manufactured, maybe the current value of that car when it's brand new, something like that. So you can see there are several items there that are changing. Okay? So this is what I mean by this something like the hash define, you're defining a certain variable that you keep on using within the program. So you don't want to have this variable as static items within the program. Because what will happen is once you write the program right now, if you're writing the program maybe for a vehicle like a Vitz, right? This thing will change later on when you come to a very different car. Maybe now you're looking for something like a BMW. I don't know. That was supposed to be a BMW. BMW, right? So it will change. You don't want to go to the entire program to start changing those things. Okay? So for that, you need to define something. Okay. So what the preprocessor does is that it will actually include things like these files, because when you say hash include, what you are asking is requesting for a certain file. I hope you remember that, right? I hope you remember those header files and all that. Right? So when you say hash include something, you are requesting for a certain file to be included within that execution of that code. So when you're doing that, the preprocessor will take out these things now, and now will actually have that file, what we call file inclusion. Okay? Inclusion. I hope you get that. I don't know. Am I recording? Oh, let me confirm. Oh, yes, I am. Okay. File inclusion. Okay. So I may not be able to write it in full, but if you go later on, maybe you want to follow up, you can see in my recording that is file inclusion, right? So you'll have also what I'm talking about in terms of like including certain variables. Okay. In some cases, you may also have what we call, what are they called? They are small. macro expansions, right? Macro expansions, right? Now macro expansions are like simple functions. Okay. So remember how like you declare a certain function that is able to do a certain task. For instance, it's able to calculate the area of something, it's able to do something. Now functions tends to be a bit more weighty. How can I say? They tend to be a bit more weighty in terms of when you're trying to call them on a program, right? They require more resources, if I may say so, or maybe even more time. Macro expansions are simpler. You can call them, you can see them as simpler functions. Okay. So that all those tasks are done by the preprocessor. Right? So you'll take the high level language, the preprocessor will do that for you. It will include those files that you need, it will, declare those variables and all that. So after that, what you get after the preprocessor is what we call pure high level language. Okay. And from here, this is where now our concern comes in this class, because we want to take now this pure high level language, okay, and convert it into an assembly language. Okay. Now the compiler has different stages within it. Now these stages are the ones that are highlighted here. Okay. So actually here we should even say, to be more specific, it should be pure high level language. So this stage over here, this second block, is now expanded to have all this. Okay. So you can see why I also said last, we can actually cover everything on compiler within one sitting and we are done. Okay. It's that simple, but at the same time it's also very sophisticated in terms of you understanding the different stages that are there. Okay. But then when you get this general overview, and that's the reason why I really like this first class, because we're just going to look at the general overview, just appreciate what is happening here, and then later on now we are going to go into the different items in here. Anyway, back here. So the compiler will take our pure high-level language, the one that has now our file included, the macro expansions, maybe some of those functions, the variables and all that, and it will turn it into an assembly language. Okay. Now, assembly language still is not something that the computer can be able to interpret, or maybe it's able to work, right? To work with. So for that, the assembly language is fed into another software module called an assembler. Okay. Another software module called an assembler. Uh, by the way, just to mention this by passing, in the past, people used to write the programming using this assembly language. If you are to go back into history, not far, maybe even when like the likes of Microsoft was starting up, IBM and all that, or even maybe a few years ago. Okay, even now there are people who still write their code could do that with this, right? But then again, as you'll see, it's not optimized for human beings to use. Okay, so in terms of productivity, your productivity is quite low when you're trying to program. But anyway, you can do that. Actually, you can cut out this so that you can just have the assembly language. You code using assembly language, and now you'll only need an assembler which is able to function there. Now, the assembler, um, this module over here, the software module called an assembler, would change or will vary depending on the kind of platform you're using. By platform, I mean, right now we are all using machines with different processors, right? So some of us are using Intel, some of us are using what is the other? It's AMD, right? AMD, all that and all that and all that, right? Now on top of that hardware, right, there is the operating system, right? So there is the operating system, something like Microsoft, something like Linux, and all that and all that. So depending on this platform, the OS, that is what I mean now, right? You'll have a different type of assembler. And something that you should note is that one assembler for one platform will not work for the other. Okay? You can guess why, right? If that was allowed, probably would be able to find that most programs that work in one platform would work in the other. So in a way, anyway, let me not go to the politics of that, but you get what I mean, right? So assembler is there. So the assembler now, not to go into details so much on these other bits that we don't need, will then convert whatever you've fed into machine code. Okay, into machine code. Now, the difference between this machine code and whatever is here is based on something that we call locating the code, because um, the machine code here, okay, the machine code here and here would be different in terms of what is it called? The allocation of maybe some of the things like the memory elements, right? Because some of the codes up here, right, may be too abstract for the machine to execute. Okay? So what the loader does, it like attaches and appendages, and appends, not appendages, appends things like the locations of where that particular code will be executed, or where the memories and the variables are going to be found, all those and all those, right? So that is what this does to come over here to the executable code. But anyway, so all this items are good, and even these ones are good, right? But our concern in this class, and I'll repeat again, is this segment here called the compiler. However, do note this, okay? So if you go and look at compilers like GCC, okay, I'll keep on mentioning this. I hope by now, because I've mentioned it several times, you've at least opened a tab and just trying to Google and see what it is. Something also like Turbo, okay? So you'll find that even though they are compilers, they will not just have this, okay? Then they require other software modules to be able to perform their other activities. What they will have is they will have all this included in them, all this included in them. Okay, so they don't have to keep on calling upon on other software modules to be able to perform. So they'll have everything. Okay, so the compiler will just be one of them. But then generally they are just called compilers. Anyway, I want to give you 1 or 2 minutes. Just go and check what GCC is, so that at least you can have a bit of context, right? Yeah, GCC is okay. Even if you don't check on what Turbo C++ is, just check on this compiler because I think I'll mention it in a short while. Okay. As I check on my power, I see my power is about to go off. Let me just connect my charger. Okay. So just open a tab, check what GCC is. Okay. Whatever you find, just say something on the chat. Okay. I see someone here is saying the battery is about to go. It's okay. Um, you can get back as soon as your machine is okay. So whatever you find on GCC, your own interpretation, don't just copy paste, just write it there. That would be nice. And then we can just talk about this and then we'll go back to my notes. Let me connect to my charger. Right. I'm back. I hope you've seen something on what GCC is. We'll probably maybe look at it later. Okay, so GCC was originally written as a compiler for the GNU operating system. What is GNU? Victor, maybe also check on that. So it's a standard compiler system for most GNU projects. Yes, what is this GNU that you keep on finding? Is it a module? Is it a hardware component? Okay, yeah, let's check on that. I think that's another general consensus that I'm seeing in every answer that is being given, where people are saying it's meant for GNU. Okay, GNU operating system. What is GNU? Is it an acronym? Check on that. Check on that. Okay, and I'll let that discussion just continue over there as I just highlight this just in a short while. Okay, we'll talk about this later on. Okay, but anyway, so let's come over here. So we've started from the high level language, we've gone to the preprocessor, we have a few high level language. So in there, we'll have these different segments that are going to be different. Is something we call lexical analysis, right? So we'll break down, I remember we mentioned this, into the different items or the different elements of grammar, right? So maybe the word something, I remember trying to highlight this using like a sentence, right? There's that famous sentence that we use to teach young kids, okay, to teach young kids on how to maybe speak English, right? And I think it goes. I think something dog jumped the boy. I don't know. I think the boy jumped over the dog or something like that. Okay. So if you are to analyze that sentence, okay, the reason why it's liked, I think I should go look for that sentence and then open it, right? You realize that it has all the different items, right, of the English grammar, right? It has things like adjectives, verb, nouns. I think it has all of them together. So lexical analysis, if you are to borrow that, the same way. Okay, we'll come back here, right, and we'll break down a certain piece of code into the streams of tokens, right? What is a token in programming? Okay, I know I'm asking several questions. This is how we'll get to understand this, right? So streams of tokens, streams of tokens. What is a token? What is a token? So we can think of it as a single element in a programming language, right? So that is what it is, right? So we are going to break it down into that, right? After that, we are going to go to a syntax analyzer, okay? Where we are going to break down all these tokens that we have into a parse tree, right? It's just a nice way of saying maybe something like X equals to something like y plus 5. Okay, so we'll break it down into the different elements and we'll come up with a tree. Okay, which will somehow highlight what is found here. Okay, something like this. Okay, we'll break it down into something all the way until to the end. Okay, this makes it easier for machine to interpret whatever is there. Right. So after that, when we get this parse tree, right, this parse tree, we're going to go to the semantic analysis now. Here, we are going to check whether this parse tree, right, okay, is making sense. Does it the meaning, right? The meaning behind the parse tree, is it there? Because semantics, you're looking at the meaning. Before you were looking at the rules, right? So now you're looking at the meaning. After that, you're going to have the intermediate code generated. I remember someone highlighted that a compiler does have an intermediate representation of the code, okay, as compared to something else. After that, we'll talk about this. Talking about this now will not do it justice. The three address code, right? So intermediate code to the three address code. We'll talk about that later on. We'll proceed to what we call code optimization. Okay. Now I know we've made the word optimization. So optimization is just a way of trying to maybe reduce some of the redundant elements. Okay? You're just trying to make your code as short as possible. Okay. You're trying to make it as concise as possible, right? So here maybe you'll have like 5 lines. Here maybe you had 5 lines. So in code optimization, maybe you're going to reduce it further to something like 3. Maybe there's somewhere you can condense that. So that is what is going to happen here, code optimization. After that, we are then going to get our target code, okay, which now we are going to feed to the assembler all the way to continue the machine code. Okay. Now, something that is very important to mention here is we have these two elements here, what we call a symbol table manager, okay, and what we call the error handler. Do note in each of these subsequent steps, the way they are going to until the end, each one of them will call upon these elements or these modules. Okay? It will call upon the symbol table manager, okay, which is a very important data structure component in any programming language because it stores some of these symbols that are used, okay? Identifiers, all those are the things that you can find in the code. So it always has them. It's able like to organize them. It's a very nice kind of like a table there that is able to have this. Also, all of them will communicate with the error handler, okay, so that in case there is an error somewhere, it's able to be reported and all that. So we can have that. I think that one makes sense that way. Okay. Now let me check my chat. I have seen it has been popping for a while with so many messages. I really appreciate that. That is good. Oh, great. So I see people are also having a discussion about the GNU. Some are saying, is it Unix? Is it not Unix? Okay, we'll see that. Ah, yes, someone even found what I was talking about. The quick brown fox jumps over the lazy dog. That is what I was talking about, right? So if you are to analyze that sentence, thank you for that. I'm not seeing your entire one. I'm just seeing Bashir. I hope that is your full name. Okay. So yes, if you analyze that sentence, right, you will see that you can break it down to the different segments of the English language, right? You can have a verb, you can have a dog, sorry, a noun, you know. What else? Yeah, I see most of the discussion is on the GNU. Oh, this is good. This is good. This is good. Um, oh, okay. I see the oh, the unique quality it has all the letters of the alphabet. Okay, that is what that sentence has. Yes, I think that's okay. Very true. Maybe I forgot some items here and there. The English language. Oh, perfect. Thank you, Bashir, for that. Okay. So yes, we have that. So that is a general overview. Um, I don't see whether there is something that is complex there, right? In a way, the thing is to do that element of compilation to move from high level to the low level language. It's not an easy task. It's quite complex, and we are going to see why it's a bit complex, right? So we require these different uh, what can I call it, phases to be able to get the end result that we need, right? Because we don't have a predefined rule, we don't have a predefined algorithm. There is no magic wand or magic algorithm that can do this by just calling upon it. So each and every code will have a unique component about it. So you need to make that code pass through these entire processes for you to have the target code that is going to be fed to the computer. Yeah. Okay, let me go back to my notes. Um, so this one, I haven't attached this one in the notes. So someone can remind me maybe later on as we start using the e-learning. Oh, I need to check on the e-learning. But in case you want to see it, you can always go through the recording and you can take a screenshot of it. Okay? Yet, let me just leave here. Oh, wow. So today we are 87. Oh, are we that many? Can someone confirm? Can someone confirm? The other day I met, I had very few students. We are 87 students right now. That is good. If that is the
We are more than 87.
oh, so okay, right? Oh, so I
Yeah.
was just thinking maybe someone just gave the link. I have aliens in the house. Okay, it's good. It's good. It's good. Perfect. So you can let the other know that they need to join the class. Things are starting to look good. Let me go to my notes. Good. So we are back here. We are back here. Okay. And now go here by starting talking about the classical compilation process. So we have, like I said, the simple C source code over here that you've written, whichever you can think of it in any way that you want to think of any programming language that you've ever written, right? You've written a very simple code that is supposed to do certain things. Okay? The simple code that we are used to, hello world, find the area of a circle, I don't know, circumference, blah, blah, blah. I haven't said the word circumference in a while. It seems weird. So anyway, so such a code, this source code is optimized for this, right? Like I said, even looking at it, even if you haven't done any programming in the past, even probably maybe a year, I don't know. I know students. I was one time back, right? So even if you haven't looked at programming in a while, you can make sense as what is happening here, right? It's very easy to see that there are things that are happening. You can maybe remember there's a certain syntax that is needs to be followed, right? Something has to be done. Okay? So what I'm just trying to say about the source code is that the presentation matches some notions of grammar. Okay? So there is a way that you are able even to read that code and understand it. Okay? Things like functions, okay, things like variables, all of them are named in a way that you can understand them. Okay? There are no special characters that are being used to refer to certain memory spaces or locations and all that, right? It's just meant for us to understand it. Okay. Now, if you are to consider now a similar code, right? Now, in this case, done using GCC, and in this case, it's done using the Intel platform, right? Like I said, you'll find that they will change different depending on the platform. If you are to go there, you'll find that this code is a bit complex. Right? It's in a way optimized for hardware, right? It's optimized for your computer to work with it, right? Maybe you can make headway into what is happening in some segments, but in others, it doesn't really make a lot of sense. There are a lot of special characters that are being used. Some of them are the syntax that is followed when you are referring maybe to memory spaces and all that, right? So all these things like move. Okay? I remember, I think I'll mention a bit of assembly later on. You'll see how assembly language works. Okay, so you'll have to like mention a certain thing has to move into a certain location. Okay, you'll have to mention maybe when you're talking something like X, like that, right? You'll even have to mention that this one maybe comes after, sorry, Y comes after X. So you'll have to mention these things, right? Because you can't assume anything. So that's the reason why you're finding this code is a bit detailed in terms of the characters that are being used, okay? In terms of the expressions that are being used, because here you can't assume. Previously, up there, right? By stating some things, you could assume. Actually, the coding that is done in the human language, it's not pure grammar, right? You'll find that uh, it's a form of like a skeleton, right? It doesn't make grammatical sense, right? In the way that you can read it, the normal way that you read it, right? But for this one, you can't assume, right? Because the computer needs to know where you are placing a certain variable, it needs to know where you are placing this constant, all that, right? So you have the code consists of things like machine instructions. It contains registers, right? I know you've done registers before. Things like unnamed memory locations, all of them are referred here. Okay? So from this simple representation, you can start to see the complexity of compiling something. Okay? Because you need to move from one language that is optimized for another person to another. Anyway, not to bore you with a lot of that because I think I've mentioned that several times. You can go to my next slide. Okay? So, like I said, during that process of compilation, we don't have any magic algorithm, right? Uh, we don't have a certain item that we can call upon so that when we are trying to translate or we are trying to move from one level, one opponent does that with magic, right? So you need to process each and every code uniquely, right? Each code has to be executed in a unique way, and for that, okay, we cannot do the compilation in one sitting, right? We cannot just have one box, okay, and just call it the compiler so that it just takes this. and then goes to whatever it is, right? We need to analyze and break down whatever code you've written. You've written some lines of code, right? There is always some indentation within the code, something like that. We need to break it down into the different segments. We need to break it down to the syntax level, right? To understand whether the rules are being followed. We need to break it down to the meaning, the semantics, so that to see whether they are making sense, right? And that's the reason why you'll see that most compilation process will follow different stages. Okay. For instance, if I was to start compiler, right, what we call the two-pass compiler, you'll find that there are two broad stages that are followed during the process of compiling. Now, those are the segments that I had highlighted before. These ones here. Let me show you. Okay. These segments here, right, they will be contained within those two segments, right? We'll see where they will lie, each and every one of them. Okay. But in general, right, we can break down our compiler, okay, into this. Okay. This is one of the classical representation of a compiler, right? The two-pass compiler. We can have a three-pass compiler. We'll look at it towards the end. Okay. But this is one of those simpler ways of representing how a compiler works, right? So in this case, we are going to have our source code, right? For example, in C, whatever it is, and it's going to meet the front end section, front end section. Now, the front end section will contain things like um, the syntax analysis, right? Syntax analysis, okay? So in syntax analysis, you're just trying to check whether the rules and the structures of that programming language have been followed. Now, something that you notice here is that the front end is also linked to the errors, okay? So that in case there's an error here, it's able to be reported. Right? After that front end and all the activities that are done there, right, we then head to the intermediate representation of the code, right? We'll get to learn what this is and what it does, okay, and how it operates. After that intermediate representation of the code, we then go to the back end. Now, one thing that you'll notice here is the front end, okay, tends to be a bit simpler in terms of its operations. Okay? Actually, we refer to it in the sense that it's able to use a polynomial time complexity. It's what we call, it has the attributes of polynomial time complexity. What that means is you can find a formula that is able to define what is being done by the front end. For instance, take the syntax, what I'm talking about. Okay? There's a certain way of writing the C code, right? A C source code. Okay? There is a certain rules and structures that are followed, right? So there are rules there. Okay? That is what I refer to when I'm talking about this polynomial time complexity, right? You can also try and see what it is deeper. But anyway, so that is what it means, right? There are predefined rules of how that is able to work. So the front end, this one, tends to be a bit simpler, okay, when it comes to its operations. Right? It's a bit simpler and even easier to understand. Okay? However, the challenging bit comes here, the back end. The back end uses what we call non-polynomial completeness, in the sense that here, okay, or non-polynomial complexity, right? What happens here, okay, doesn't follow a certain rule. Okay, there is no what can I say? What can I say? What can I say? What can I say? So, for instance, let me just give a general example, right? So, there's this. What is the formula for a straight line in a graph? If you remember, there was that, and then there was a curve. Okay, for instance, the one I think this is a curve, right? Mx plus c, right? Okay, something like that. Okay, so if you have to think of it, the front end would have such a definition. Okay, if you are to analyze it mathematically, right, you'll have such a definition. Right? However, the same thing cannot apply to the back end. Why? Because each and every um, execution of a source code which is trying to be translated to machine code will have some unique traits. It will have unique tokens. It will have unique elements. Sorry. So because of that, you cannot have a predefined formula like this that is going to work for it. Okay? However, the front end, because it's just checking whether the rules and other items are being followed, it's very easy to have something that is predefined. But then the back end, which is doing the actual analysis, right, and which is actually breaking now your source code into the different segments so that they can be interpreted to now the zeros and ones. Okay, you cannot have predefined rules, because if you have predefined rules, it means there are certain things that are going to be seen as errors. Okay, whereas they are not errors, just that they are unique and they are not defined there. Okay, and we'll see where the errors for the back end come from later on. Good. Um, so yeah, so in general, when you look at a compiler and maybe a classical compiler, which has two phases. Okay. Now the two phases or the different phases that are being followed, whether two or three or whichever it is, right? They are organized in such a way, okay, that they try and simplify that entire process of converting high level language to the low level language. Okay. And here I think I have a more detailed uh, description of that compilation process. Okay. So you can see the source code, you can see the front end here will contain things like lexical analysis, the parser, the semantic analysis, right? Middle end where certain things are optimized as well also. Okay. Then after that, we then go now to the back end. Now the back end is the one that I'm saying is a bit complex. This one, okay, this one here, and actually, maybe you can say that most of the work is done here, as we are trying to get now from this back end so that we can go to assembler, our linker, and finally go to the executable code. At the same time, also I've also highlighted this. Okay, that you can see maybe the GCC is trying to compile the C code in multiple platforms, right? So, for instance, in Windows, in Mac OS, in Android, right, and how it operates. So, right now, this may appear to be very vague, okay, but with time, it will start to make more sense in what it is doing. Yet, yet. So, there's a very nice next slide, uh, and I wanted to pose that question as we have a very short break. I need to sip some water, okay? Because we are about to just discuss the two ends. So I'm just going to discuss the front end a bit and then discuss the back end a bit. And then later on, I'm just going to mention the three-pass compiler. And then I think that will be enough to have highlighted the entire process of compilation. So that the next thing that we're going to talk about now is lexical analysis. Okay? So I think I'll ask the same question that was just about to be asked here. Then I'll give you a few minutes to just think about it based on what you have right now. Do you think it's possible to have more than one front end? This section here. Okay. Okay. And maybe the question that you may ask yourself is why would you need multiple front ends? Okay. Wangari, I know I'm answering your question using another question, but let me ask that. Okay. So why are you thinking maybe you may need another front end? Okay. Are you trying maybe to okay, and maybe that will lead to the answer. So why? Okay. So a few minutes and then we'll be back to discuss the front end and then the back end. But put that in mind. Let me just paste this question to everyone because I see it was, I think, sent to me privately. But the question is why? Why would you need multiple front ends? Be back in a few. Nice. I'm back. I'm back. I'm back. So before we had our short break, I will give you a longer break in a few minutes. As soon as I cover front end, I'm going to give you a longer break. Or maybe no, we can cover until the back end, and we'll see. And then we can have maybe like 15 minutes. Then when we come back, we just finalize the entire chapter. But anyway, so there is a question that was asked. Okay, and I almost gave you the answers, and the answers are aligned to what I'm saying. Okay? So we asked, is it possible to have multiple of these front ends? And to answer the question that was asked, I posed another question and I asked, why would you need another front end? Okay. So by now, I hope you're looking at front end in this way, right? Okay, in this way, right? So it's taking our source code. Okay, that is what the front end is supposed to do. It's taking our source code, right, and it's breaking down into the core components of a certain programming language, if I can say so, right? That's where you can see things like lexical, right? The different tokens. That's where we are going to find the different streams there, right? We're also looking at things like grammar in there. Also, we're also looking at the syntax errors in there, right? So we are just trying to take the code, simple terms, and just breaking it down into the different segments. So that is what the front end is doing. Now the question comes: why would you need to have multiple items that are able to do that? Are you there? Hmm? Maybe it's disappeared the network. Can everyone hear me? I hope you can hear me. I don't be the one who has gotten cut off from the network. Okay, yes, say something. I see you've activated your mic.
Yeah, so can you hear me?
Yes, I can.
Okay, so I think that there are some programming languages
Okay.
that try to combine like, they try to get like the advantages of a, let's say a lower level high level language,
Okay.
like let's say or C++, and maybe the advantages of Java.
Okay.
So I don't know what language it was called, but yeah, it was trying to do something like that. So in its operation,
Okay.
you type in that programming language, but I think it converts that into C. So in that case, it's like there are two languages. So you'll type in one languages, then it's converted to another language, then that language will now be converted into C.
Okay.
So I think in that case, you'll have two front ends, each for like um, doing the lexical analysis and all that for a certain programming language.
Okay. Okay. I see what Anthony is saying. I see what Anthony is saying. Correct me if I'm wrong, Anthony. There's someone who said something here on the chat. Let us just all of us go there. I don't know that you can see it. I hope he sent it to everyone. Jeffrey. Jeffrey, you sent it to me. Allow me to send it to everyone. Let me just copy paste it. Or maybe Jeffrey, you can copy paste it to everyone. Okay. So Jeffrey is saying we can have more than one front end, maybe for deployment to multiple platforms. Okay. He's giving an example there. Okay. Which is trying to deploy maybe into something like you're trying to deploy a code both in iOS and Android. Okay. Think about it. I don't know. Has he pasted it? Okay. Okay. Let me just try. Okay. Yeah. Just read that final comment there as I go through the others. Okay. And try and tell me whether that makes sense. And Anthony, tell me whether it links to what Jeffrey is saying, because there's a bit that you're cut off. Just write for me there and tell me whether you agree with that. As I see what else someone else has said over here. Okay, so someone else over here, Vanessa is saying, since compilers are language specific, multiple front ends can help in converting code written in different languages. Okay. Also, keep in mind whatever Vanessa has said. I also like that one. Okay, so Brian also here says multiple front ends for multivariant code. I agree with that. Okay, so I think all of you are thinking within the same line. Okay, somehow different in the way you explain it, but I see you are somewhat headed to the same idea. In the case, Miriam, in the case where one is dealing with multiple languages, EDC and C++, one can have more than one front end to check the syntax for all of those. Okay, now that's a different view there, right? No, no, but I think that's also similar to what Vanessa is saying. I agree with that. I agree with that. There can be more than one front end in a compiler in a machine so as to enable you to compile different languages. Okay. similar concept or similar idea, but different words being used. Again, I agree. When dealing with different languages, yes, Eric, yes. So to compile similar programming languages, yes, 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 yes. Okay. So think of that. Yes, I see another hand.
Okay, it's a question actually. Like,
I can hear you. You've just gotten broken off. Just repeat.
can you hear me?
Yes, I can hear you now.
Okay, my example would be like something how maybe your compiler is able to compile different versions of a specific language. Like maybe
Okay.
the syntax in Java 8 might be different from the syntax of previous version
Ah,
or earlier
uh-huh.
version.
Okay, 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 okay. Did you get that one also? Right. So look at something like Java, like you said, right? The different versions that are there. Okay? So you may have the front end, right, having different segments so that you can be able to deal with all those. Okay. I may not be able to go into those, but I think I can do some research on that and maybe see whether I can come up with the write up and then attach it later on. But you'll give me some time, okay? But I can give the description of that front end and maybe why you may have multiple of those. Okay? Also, the question: if you have multiple front ends, let me pose this one. If you have multiple front ends, that mean that you'll have multiple back ends. What do you think? A question. Okay. If we have okay, it appears simple, but take your time. Take your time. What do you think? For instance, yes, 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 Isaac.
Okay, so for me, I was trying to look at the reason why compilers might have that division of front end and back end,
Okay.
and I just realized that one of the reasons could be portability, because let's say
Mhm.
I have a C compiler
Okay.
that probably works on an 8080X hardware
Okay.
and on, like, let's say another different type of hardware.
Yes.
You can write one front end that will be used in both of these hardwares, but
Okay.
the back end will be different so that it can be able to uh, process, get the 8080X version and work on it, and also on the other particular piece of hardware and work on it. So it
I
forms
can't
that
hear you.
aspect of portability.
Just repeat that final segment.
So it backs up that aspect of portability, so it can be
Okay.
used on
Okay.
the different hardware. Yeah.
Okay. Okay. I agree with that. I agree with that. So Isaac has brought a different argument, which also I don't know whether all of us have seen that, right? So think of the hardware now, the platforms. Actually, what he's talking about is the platform now, right? So maybe you're going to execute the same code in different platforms. So in that case, you may have a front end that is one, but then the back end are different. Anyway, let me read what is being written on the chat. I think the discussion is lively today. So Amani says a concern if we have many front end, does it increase the use of computer resources? Okay, more questions. To what extent can we have multiple front ends? What is the advantage of having these front ends? Okay, okay, okay. Someone else over here, someone else over here. All these questions, I hope they are to everyone. Oh, good. Yes. So can we try and write all the comments to everyone so that at least all of us can contribute to the discussion, right? So you can have the same front end, but with multiple back ends, one for each target machine, since the back end majorly deals with the target machine. Yes. So the one that is actually the idea that has been brought up by Isaac is also, I think that one is more, you may find even more literature on it. Okay? Because of the idea of that idea actually of portability, okay? Where you have, because in most cases, okay, the compiler that you have, right, will take whatever source code you've written, right? In most cases, right? Uh, Now, personally, I was thinking if the front end will be multiple, it's just a matter of you maybe trying to optimize what you are trying to work with. Maybe the idea of having working it in multiple languages, but then you'll find that the efficiency or the convenience that is brought by it may not really matter. Okay, and I'll back up that with different words later on. But this one that has been brought up, the one by Isaac, where you're looking at the front end being one, and then there are multiple back ends. That one makes more sense, especially when you consider the multiple platforms that you're able to work with today. Okay, because you may have the same code. For instance, something like I'm thinking of something like WhatsApp, right? So WhatsApp, right, will work in the multiple platforms that we have. You'll have your Android phone, Windows. There's a Windows version, right? I don't know. I always use the web thing. Okay? Then after that, also there's iOS. Okay, so you'll find this will remain to be the same when that person is writing the code, because right now we are looking at ourselves as the people who are developing. okay, developing, right? The people who are developing the code, right? So these guys at FB, or the guys who came up with WhatsApp, right? So the front end will be the same, right? Because they're just typing the same code for the same thing. But then whatever is going to be executed is going to be executed in multiple platforms. So in that way, okay, I'm not refuting the idea of having multiple front ends. Personally, I'll be honest, I haven't tried to think about it in terms of having multiple front ends. Which this is the reason why I like the question. Okay, but I have thought of it in terms of having this. Okay, having multiple of this. Okay, so that at least you're able to optimize this process of just executing the code in multiple platforms. Okay? Anyway, I stand to be corrected. Just think about it. The good thing about some of these concepts is that they are up for discussion, right? Also, I encourage, especially this, I actually encourage this to my students. If you find a point where you're finding there's a gap in literature, okay? For instance, what I'm talking about right now, right? You may find that there's a gap. Not a lot has been written, not a lot of research has been done, right? You can always do it, your own research, and then write your own papers, academic papers, and actually those ones will give you even more weight when it comes to your career. Okay? So those things that we've just discussed within the past few minutes, I can assure you are researchable areas, very strong researchable areas. And anybody who is interested in doing a bit of research, I advise you to note those two subjects, right? And just try and think about it and write something. Also, like I said, if you do highlight something by email, I always give you points. But I like the discussion. Okay? Um, Let me see. Allow me just to come back to whatever has been written on the chat in a short while, because I want to cover at least the front end before we are able to have our break. Okay? Anyway, so these are front end. Okay? If we are to go deeper into the front end, we can find that it can be split into two major items, what we call the scanner and the parser, right? Sorry. And what we say the front end does is that it is trying to break down our program, our source program, right, into the different items of a certain programming language, right? And this is the reason why you'll find words like this. Okay? We are trying to use the front end to recognize any legal programs. Now, legal means it's following all the rules of the ethical and all that. So here it means in terms of the rules, right? So if it does follow the rules, we allow it to move ahead. Okay. However, in most cases, when you're writing code, in most cases, especially lengthy codes, right, you'll always encounter errors, right? So you'll miss a parenthesis here, you'll miss a semicolon somewhere. So in that case, this front end also, okay, will be very useful here because it is going to report for you these errors, okay, so that these errors are not taken to the intermediate representation and maybe later on to the back end. Okay? So here we are going to like filter, okay, just scrutinize the entire code so that you can have a good working code in terms of it being legal by following all the structures, especially what you're saying about the syntax, right? The syntax. Okay. So for the legal programs, the front end will produce an intermediate representation of this code. The front end, and we are going to the back end, you'll see that we are slowly moving away from what us as human beings understand. Okay? So we are breaking down, we are trying to break down our code into simple tokens. Let me even use the word tokens, right? Into simple elements. Why? Because if you have to look at the computer, like I said before, can be reduced to a switch that is able to recognize a high or a low. It's that simple, right? So that's the reason why we are trying to optimize our code to the level that we can bring it down to this minute level. Okay. So anyway, so some of these intermediate representations, right, will form of a kind of a compromise between what you'll see in us as human beings understanding to what will happen on the back end, and later on will be led to be fed into the assembler, okay, to be converted to the machine code. Anyway, so we'll have the scanner and the parser. Okay. Um, I know by now you can already have an idea what the scanner is doing, right? The word scan, you can already see that, right? It's like you're just skimming through the entire code and just trying to identify some items, right? So that is what the scanner does. Actually, there is not so much that is being highlighted here, right? It just does that whatever the word says, right? as we are accustomed to by the word scanning, right? Scanning. So it takes a program to the input, and then it will kind of like identify the different items that are there, right? The characters that are there. It will just mark them out, okay? Mark them out. But at the same time as it is doing this, right, it's following a certain syntax. Okay, there's a certain syntax, there's a certain rules or certain structure that is being followed. So that is what our scanner is doing. Okay, and it will not only produce the different elements of that programming language, which is based on the syntax of that programming language, right? Right. It will break it down into what we call tokens. Okay, this is where the idea of tokens comes in. Okay? And I want you to take a minute and ask yourself what a token is in this context of programming, right? Yeah, I know if you start thinking it in a broader sense, tokens, you'll start hearing about KPLC. No. Okay. I want you to think about tokens. What do you think tokens are? What is a token? Because if you understand what a token is, you'll get to understand why I'm talking about here, taking a program and then it's forming like streams of words in quotation marks. I didn't want to use the quotation, the name words, okay? Because it can be a bit confusing. I'll prefer to use the elements, right? Something like elements, right? So that you can understand why I'm talking about us having here the scanner identify things like the token type and the word, or this can be the element or something like that. Okay? So for instance, you can see this thing that we've written here. X equals to Z plus Y, Z plus Y. Let me use Z. I will start Z, not Z. X is equals to Z plus Y, right? So we are breaking it down to the different components, the different elements, right? Okay. Yes, I like the answers that are coming through the chat. Okay? Let's all of us go there. I hope you have your screen in such a way that you're able to see the charts and at the same time you're able to see what I'm sharing, right? So I think all of us are agreeing on the same thing, right? Some are saying the smallest unit of a language. Jaden, I agree with that. Hubert is saying a token can be a single element of a programming language. Okay, so you're looking at those minute, small element that you can break down your programming language into, right? The smallest element, the smallest divisible element. I agree. This Waweru, Newton. Hey, there's someone called Newton. You know you have a very big name to live up to. Eh? Then we have Derek over here saying a single element of a programming language. I agree with that, Naomi. Basic unit of a programming language. Token is a series of bits. Okay. Now this one is even better by Helen. She's going now to the lower level, right? You're looking at it in terms of a machine perspective. I agree with that. Could be a keyword operator. I agree with that, right? Because that can be a single element in a programming language. All that and all that. I agree with all that. Okay. So yes. So look at this. Continue with the discussion. I have no problem, but follow with whatever I'm saying, right? So, for example, you have an input X is equals to Z plus Y. That is our input. Okay. So the scanner will break it down into this, and you can see as the way we are putting these, it's like the hash includes over there, right? So you'll see here will be like an identifier X. There will be the assign, which is an operator. There will be another identifier Z. There will be an operator plus. There will be an identifier another one Y. Okay. So you break it down into that. Okay. Where the scanner now will group these things into terms of having a token type. Okay. What I'm calling something like an assign, an operator. Okay. All that. And the word. The word in this case will be something like a letter or the actual symbol itself, something like that. Okay? So that is what the scanner is doing. So the scanner is skimming through your code. It's skimming something. A machine that is doing that, right? I don't know why I've forgotten the guy from Star Wars, the robot from Star Wars. CP3O, or is it? I think so. Yes. So he's scanning there. You know that scanning sound, right? He's scanning. Yes, C3PO. Thank you. Right? Newton with the save. Yes. So it's scanning through the entire thing. Okay. And then after that, right? It's able now to break it down into these different elements. So I hope that is okay. Okay. Let's move on. I don't think there's anything complicated there. Let's just finalize here. Okay. Then, no, I want to go to my slides. Then after the scanner, we are going to go to the parser now, right? We say there are two major groups, or two major items, not groups, two major items on the front end, what we call the scanner and the parser, okay? So the scanner now will take now the token, right? There will be many of them, okay? And it will recognize them into what we call a context-free syntax. A concept here that I tend to think is often ignored when people are learning programming. I don't know whether when you are taught the basics of programming, this was ever highlighted, context-free syntax. Okay, now, unfortunately, in most cases, people tend to ignore this item. Okay? What do you think context-free syntax is? Okay? I have given here the syntax of most programming languages specified using what we are calling CFG, context-free grammar. Okay? And I've even given an order of how the context-free grammar will work. It will have a symbol, okay? It will have non-terminal symbols, okay? It will have words, okay? And then a set of productions. I'm leaving this item open for one reason. I want to invoke your curiosity. Okay? If you look at most programming languages, okay, the syntax that is followed, yes, it follows the grammar of a certain language, a human readable language, something like English, right? But then it doesn't, I don't know whether I'm making sense when I say that it doesn't follow those exact rules of that grammar, right? It's like it has its own set of rules. Remember the pseudo code? Yes, yeah, I think there's a pseudo code. You remember that thing that you learned about having a pseudo code and how it appeared? So when you read it, it didn't make grammatical sense from the English language perspective. Okay, but from a programming perspective, it made a lot of sense. Okay? So I'm bringing this idea of context-free syntax to invoke your curiosity. Go and learn about this. Okay? Okay? And if you have time, try and think of how now programming languages are developed. Right? So something like how Python was developed. Right? So I remember the person who came up with Python. I don't know whether this is true or lie. So apparently he was tired of having so many things that you see them in other programming languages. So he just wanted something that he just directly just inputs whatever he needs and he's able to get the results. Okay? Anyway, so after the scanner, sorry, okay, we are going to have the parser, right? And the parser here actually is in fact going to help us to break down even further whatever source code that we have, okay, into the different elements, into the different tokens that we have. Okay, it's also through the parser, right, that you're able to get the parser tree. Okay, I'm skipping some of these things because we'll talk with them in detail later. Okay, using the parser, that's how you're able to get this representation. Because remember, like I said before, our objective is we are trying to break down whatever we have in this human language into something that the computer can readily identify very easily. Okay? And that's the reason why I started by maybe highlighting something like a tree. Right? So the parser, after getting the streams of tokens, using the context-free grammar syntax, it's able to break it down into these different segments. For instance, you'll have the goal. Now the goal is the original maybe expression you have, something like x plus y minus no, it's x plus 2 minus y, right? So that is the goal. So you see how this has been broken down into the different elements as specified by that CFG, right? So here we have the expression, then we split it into the two different expressions. We broke it down all the way until to the level where we have now the identifier x, we have the operator, we have the number, and we have the identifier. Okay? So, well, we may not need to understand too much about CFG. That's the reason why I just mentioned it. I didn't want to go into details because if I go to details, people are just going to ignore it. But at least when I mention it and I ask you to just go and check, in case you have a question, I'll just repeat it later. We'll deal with it. You'll get to see and maybe understand how this division was done all the way to the end. Okay, but then the idea again, I keep on repeating, right? We are just trying to simplify our code into something that the machine can readily identify, right? Remember, our machines, right, tend to be more supervised, right? I'll keep on drawing this again. You have like two options, which now over time, depending on the number of bits you have and the processor size you have, you'll have more switches, right? So that means you need to break down your code into something that can at least be identified in terms of these two options. This brings me to another question. It's a bit out of the context of what we are talking about here, but allow me to talk about this. Let me ask. So I'm currently teaching a different group in digital logics, and one of has been asked so many times. I wanted them to answer that question with regards to whatever they had learned in digital logics. Digital logic is all about learning about bits and maybe logic gates, things like logic gates and all that. So I wanted them to answer that. Okay. So the reason I'm asking this question is Okay, if you get to understand why machines maybe don't have the intelligence of human beings, you get to understand why this entire process is needed. Where we keep on breaking down these things to simple elements and simple tokens that can be easily identified. Right? You as a human being, right? You as a human being, okay, you are self-aware. You also have a level of intelligence, right? You have a level of intelligence that is able to assist you to identify things that are not predefined. But a computer cannot do that. Okay. Anyway, I'll leave that on to you. If you have an answer for me there, do share it. Okay? Do you think computers more intelligent than human beings? I would like to hear that. Anyway, so I'm thinking we can take a short break, and then we'll come back and just finalize everything, and we can see what's next. Okay. But where you're at it, just think about that. Think about CFG also at the same time. Think about the question that I just posed, even though it's not directly related to a class, about computers and human beings. So we can have 15 minutes, and then we'll be back. Okay. Right. Going on mute. And through the parser, how it's able to break down and take the streams of token developed by the scanner, it's able to develop the parse tree, okay, which is like a graphical representation of what we have. Now, the compiler, okay, the compiler, well, this is a representation that us as human beings are able to develop using the rules of the syntax CFG, right? The compiler itself, when it's coming up with its own parse tree, doesn't have all these details, right? It has like a simplified kind of like a parse tree, right? So in this case, it do not have all those details that we had, expression, the goal, the operators, the term. Instead, it will just give something as simple as this, which highlights the same point, right? Here the identifier X, the number, things like that, and all that to the end. Okay. In fact, yes, here's the name that I was looking for. It uses what we call an abstract syntax tree, right? So from the looks of it, it's not easy to make heads with what is happening here, right? It's very abstract, right? It just takes what it thinks is important and just highlights them, right? The different important tokens, right? So you are seeing a token type together with the word, or a simple token type together with the word. So as simple as that. So this representation is more concise. Okay? In this case, we are just summarizing the entire grammatical structure that we have up there. Okay? So that we can take this representation now and we can have now the intermediate code, okay, which is now going to be fed now to the back end. I would just like to highlight the backend, and I think I'm just going to highlight it here because even though it's important, okay, what will happen later is more key, right? So the backend will take now the intermediate represented code, okay, and it will continuously do these different operations, right? Because the backend is just trying to take the intermediate representation of the code, which we can see it as the parse tree, right? You can think of it as that, okay? So that representation that was in somewhat graphical representation form, something like that. Okay, so we are breaking down to something like this, all this, all this. Okay? So it's taking that, okay, and it's translating it now to the machine code. Okay? Remember objective, we want zeros and ones, we want zeros and ones. Okay? So it chooses the machine instructions to implement for each IR. So for each intermediate representation, right? Because as you feed the content, you may have multiple of these. Okay? You may have multiple of these intermediate representations, right? If you take each one individually, right, the instructions that are set there by the assembler, right? So the backend also, this item, will also ensure that your code conforms with the system interface, right? So this is where the idea of the different platforms comes in. And this is the reason why I tended to agree with whatever Isaac was saying, right? In terms of having like a single front end, but then the back end are different, right? So that each one of them is specialized to deal with a certain platform. So one can deal with something like Android, the other one is dealing with something like Windows, and then we have something like Mac, something like that. So the backend is the one that is able to do this. Okay. But anyway, so this back end, as you would expect, right? It's more inclined to the machine code. So that's the reason why you're seeing here. Okay, we are starting to talk about things like registers. Okay, we are starting to talk about things like the memory access. Okay, so it's the back end that is able to somehow what can I say this? Structure the code in such a way that it's going to align with where the registers, the necessary registers that are going to be used, okay? And maybe to make sure that each and every code that is used does not avoid any memory access, right? It's able to be directed where it's needed. Uh, but anyway, this representation over here actually suffices, even without going through the other slide. I'll mention them. But if you are to think of the backend just performing the instruction selection, right? It's the instructions that we have, okay? Then it's able to allocate each and every code to its register. Okay? And also, because multiple instructions will be given, right? Multiple instructions will be given. You need to have a form of like a also, as you can notice, similar to the front end, each and every item here that is done by the backend is connected to the error handler. Okay, so that to check for any errors that may arise during the process. Okay. Let me just brush through the other slide because I don't think there's anything that I'm going to say that is new, right? It's just I'm just extending that. Okay. I'm also highlighting here. I don't know whether I still have it. I don't know whether I have it. Let me see. Let me see. There's something I'm looking for that I think is the most important to mention in this case. Yeah, there is this item over here, right? So I think this one is obvious, right? That most modern processors have a rich instruction set. That is important. What I'm looking for, yes, it is. So instruction selection in compilers, okay, was actually, we can say that it was somehow like ignited by the development of this complex instruction set computer architecture. Okay, so what is this? CISC. I don't know whether you've met it somewhere, okay? Because um, this first item over here, the idea of selecting the instructions that are going to be used, right, was actually instigated by the emergence of this. Oh, I've given it here. I've given it here. Now this one is more inclined to the hardware components of computers and how they operate, right? But I felt it's important to mention it here, right? Some of these things I may mention them towards the end. As soon as we are done with things like the optimizations of the code, we've gone through the entire phases of compilation, right? I may mention them, but then I'm just having them here for anyone who is interested. You can go through them, right? Just go through them, uh, read a bit wider, and you can get to understand. A final thing that I think I should mention is the three-pass compiler, right? So remember, so far, this class, I've been talking about the two-pass compiler. It is, right? I just spoke about having a front end and a back end. But then you can also have a three-pass compiler, which means you'll have three major segments. It is, okay, where you can have the front end now instead of having that intermediate representation as just a transitional phase, right? As transitional phase, you can have actually somewhere where we have a complete designation of that, like intermediate representation of where we are calling it the middle end. Okay, so you can have such a representation. Are there advantages to having this? Yes. Why? Because of this, it makes this transition. You said before it was just a general transition. As soon as you had the front end, maybe things like the tokens and the pass tree, you're able just to go to the back end. Okay? So that transition in some cases, for one reason or another, right, maybe a bit complex, okay? Depending on how a unique code is, depending on the number of tokens you have, how complex those tokens are, the number of variables you're calling upon. So when you have this three-pass compiler, right, it's able to make that transition more efficient. Okay, more efficient in the sense that you can further even break down whatever you have at the front end to suit better the back end. Okay, and if you are to look at maybe and analyze most of the modern compilers that we have nowadays, okay, so most modern compilers are starting to take this kind of a structure, okay, where they are not having just the front end and the back end, they're having a middle end over here, which also tries to optimize whatever you've gotten from the front end. Okay? So remember, the idea of optimizing is very important. It's very important because you're just trying to make this code as simple as possible so that our computers can understand it. Like I said, our computers are not intelligent, so they need some predefined elements to be able to work. Okay? So the middle end over here for a three-pass compiler, right, is nothing but an optimizer. Okay? So it's just trying to optimize our code. That's all it does. Okay? So it's just trying to optimize our code so that it better suits the activities that are going to be conducted on the back end. Now, in that, I did highlight some segments over here again. This is also bonus material. Okay? I'm just talking about the optimizer and maybe what it does using a flow chart. Okay? I'm hoping this is going to invoke your curiosity as we continue looking at the different phases of the compilers, right? You'll be able to reflect back and can see some of these items that have been discussed here, okay, over and over again. Anyway, I wish to stop there for today. I haven't seen the e-learning being up yet. So what I'm going to do, I'm going to convert this into PDF and I'm going to send it to the two class reps, okay, so that in okay. For now, let me just check and see whether there is a relevant question to what I've just said right now before we go back to other discussion. Huh. Ngugi John has a very interesting question here. I think people here are very, very, very curious, which is very good. So, if a compiler is a computer program, how was the first compiler written? Was it machine code? Okay, 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 okay. Now, if you remember, Google, maybe just to avoid us having a very lengthy discussion, so at least we are able at least to reduce the number of questions. I talked about the assembler, right? You remember that? And I was talking of it. Let me just go there. I was saying that some of the original programs that we have, especially back in the day, were designed using assembly language here, right? So you can see it's like they had cut off this person over here. Okay, so yes, you are right. I think you actually answered your own question. So yes, they were written in this form. Also, if you are to go even deeper, okay, back into further, okay, and go back to those computers that used to use not even machines that used to use punch codes. I don't know whether you remember them, right? So there is like a card that has a series of slots that is able to guide the computer to work, right? And a computer and a machine to work that way, that way, that way, that way. So if you have to look at it that way, you realize that those computers were actually working with machine code because what you'd written here was a machine code. So yes, so over time the compilers have cropped up because of the advances we've had in computers of us being able to maybe have more software modules and all that. Okay? Perfect. Perfect. I see so many messages coming through. I'll probably maybe miss your question. If I've missed your question, okay, because I'm encouraging the discussion, okay, just send me an email. I'll be able to respond. Okay, if I've missed any question that you feel that was a bit important, because I see the discussion is a bit lively and I like it that way. However, in some cases, we will try to moderate maybe the discussions just to within the context of the class, but never shy away from having any discussion in class. Okay? With that being said, there were people who said something. Oh, if you have a question that is a burning question, let me just stop this share. Maybe I can take one or two burning questions. Oh, I see someone has asked the parser. Okay, so the parser is taking the stream of tokens. You remember those segment that we broke down using the scanner, right? So the scanner went through the entire code, okay, and it saw things like tokens and the token type and the word, right? So it was able to break it down into that. Okay? So now the parser takes those streams of token, okay, and it will recognize the context-free syntax. The context-free syntax means it will recognize the different elements as defined by a certain programming language. For instance, it will recognize things like operators, okay, things like terms. That's how, okay, using that way of. Let me just share this. Yeah. So the person who is asking that question. Okay. So that's how it's able to break down whatever it is given, those streams of tokens, if I was to think of them as these small bubbles I'm drawing here. Right? That's how it's able to split them into these different items. So it's able to get an expression because this is CFG that is in work here. This is a CFG syntax. Okay. That's how it's working because there's a certain rules that are being followed so that you can break it down. So that's what the parser is doing. So the parser is taking the streams of tokens and then it's recognizing the context-free grammar syntax. Also, it's also able to identify any errors that are there. I don't know whether I've answered your question, but that is just a general overview. Maybe with time, as we discuss more, you'll get to get more context within what I'm talking about. Okay, another question. Just for clarification, the compiler converts source code to. Okay, let me share that image that I had. Maybe just probably this will be important. Let me also see who this is. Good. Minor. I don't know if you can see that, Jessica. So you're asking the compiler converts the source code. So in this case, we have a source code. Okay. Convert it to a target language. Is the target language assembly? Yes. So this is assembly here. So you can see as I shown you over here. Okay. So we are taking this pure high level language and you're converting that. Also, maybe this one can help you see. Okay. Also, this one can help you see. If you are to look here, okay, the are all leading up to the assembler. Okay? So whatever is done by the compiler, okay, is leading up to what the assembler will do, and the assembler will only understand assembly language. Okay. I don't know if there is another question. I'm getting an inflow of messages. Let me try and see whether I can get another question that has been asked. So many questions. Good. I think some of them are also comments. Just bear with me. If you have a question that you've asked, I'll be able to see it. Okay, I think most of them are just comments there. Okay. Oh, there's someone who is here saying, I think you went through fast. Okay. The back end. The reason why maybe I did not concentrate more on the back end, okay, and I just was a bit brief on it, is because most of the items they are geared towards the machine, the operation of the machine. However, I can repeat, maybe just to summarize. Okay? So the main things that are done by the back end, right, like I said, are what we call instruction selection, right, register allocation, and instruction scheduling. So now, in most cases, especially when we're discussing the back end, two main things stand out that are being done here, right? There's this item of register allocation and instruction scheduling. Now, register allocation is very important because uh, I don't think you can ever have enough registers, okay, to do all that you want. Okay? It's the same thing that you can think about us having something like land, okay, land like here in Kenya, right, in a country, right? Um, you can never have enough land for everyone. So there needs to be a form of allocation in one way or another. You need to have a plan. Okay? Also note that some registers in here, if you have to go deeper into machines, right, you realize that some registers, okay, are designed in such a way that it's like they are pre-allocated for certain specialized tasks. For example, things like program counters. Okay? I know now I'm going back to some of the digital logics that we did back then, but this is what I'm saying, right? So some registers are designed and it's like they're already booked in advance. So some of those are taken out of what can be used within a certain execution of the back end activity. So because of that, you need a way to allocate this register. Now, also, this allocation, by the way, remember what I talked about as not having a magic formula for the back end. Okay? The registers also are not allocated using a polynomial kind of a complex situation. What I'm saying is there is no rule or there is no predefined formula for how those registers are going to be allocated. Okay, it's following a non-polynomial kind of a setup. Okay. Then the next item that maybe stands out in the back end again is what we are calling instruction scheduling. Okay, instruction scheduling. Okay, and here again you see the same idea that I'm bringing up, right? Okay, we need to have an order into how those instructions are going to be executed. So you've already gotten whatever you got in the streams of code, you've got in the past tree. Okay, then after that, right, you need to be able now to take those items, right, so that they are executed by the machine. Right? Again, the same process of scheduling these instructions again does not follow any formula. Okay, so it's a non-polynomial again, completeness. It follows that structures of a non-polynomial completeness. Anyway, I don't know whether I've maybe delved deeper into what I'm trying to say, but I'm just trying to highlight the back end components and maybe to be more specific, right? The front end is something that I feel you as programmers and ICT students, it's very easy for you guys to understand, okay? Because I don't know how much you've interacted with the hardware components. So the back end is more inclined towards the hardware. Okay, that's why at least I went through a bit faster. But anyway, if you have any more questions, um, so the more we advance, the more we'll go deeper into each and every item that you've seen here. Okay, perfect. Let me see whether there is another question. I think I think the idea of machine and computers has ignited a very big conversation. So let me stop checking the chat. Let me just leave that one to you guys for now. Oh, there's a hand that is up. Yes, Woiru, say something.
Hello.
Yes.
I was asking about concrete syntax tree since you didn't mention it.
Come again.
You have mentioned about abstract syntax tree, but you didn't mention about concrete.
Okay. Okay. You wanted me to highlight it. Okay. Any other question? I want to take all the questions so that at least I will answer them. So that when we are done, we can just. Yeah, I see another hand. Yes, say something. Or maybe you pressed the raise hand. Okay, I don't see any other question. I think I'll just take the one that was asked by Waweru. Okay. So when I went through this, the original one, I think maybe it's just that I didn't mention. Okay. But this representation of here, okay, tends to follow the concrete syntax tree. Okay, in the sense that it's just so if you have to look at these past trees, if I was to say so, right? We can split them into two, right? Okay. So what kind of like what the computer or the compiler will be able to highlight, okay, the abstract representation, right? Which is by the word suggests, right? It's a bit vague in its highlighting of the different components that are being viewed. Okay. Now that is different from this other one here. Okay. This one that is representing some of those the syntax structures that we have. Okay. Following the CFG, like I said. Okay. So I'm not sharing. Sorry. I thought I was sharing. Okay. So here, so this one here, okay, this one here, this is what we call the abstract syntax. We are just going direct to what we need and what the compiler may need. Okay. However, this one up here tends to be more detailed. This is what we call the concrete. Okay. Uh, the word concrete, you get what I mean, right? As in, it has more components, has more items being highlighted, and then it's following the CFG syntax. Okay. So Waweru, maybe just to answer you, when I went through this, okay, in a nutshell, I was explaining the concrete pastry. Okay. I don't know whether that answers your question. If it doesn't, I'll be glad to expand on that. Especially, let me check. Let me check when I'll be dealing with the past representation, so that we are able to expand a bit more. Just give me a second. Okay, So I'm seeing maybe probably on the third or fourth class, probably I'll be able to expand a bit more on that. Okay. In case you'll have more question or error, I hope you'll be there so that we can expand a bit more there.
Okay, thank you.
You're welcome. You're welcome. What the message are so many. Anyway, it is good. I like the discussion that is ongoing. But now, maybe next time when we have a discussion that is outside the context of the class, maybe we can just hold off until towards the end right now. Okay? Let me just finalize on something here. I think what is left is what? Good. So there are several students who have activated their mic today. If you activated your mic and said something, just write your admission quickly. And I would request kindly for the next few minutes, just hold on to the discussion so that I'm able to get those numbers. I was not able to take note of them. I usually take note of them. I don't know why I forgot. When each and every student was able to say something. So if you said something via the mic, just have that. For the rest of us, if it's in terms of attendance, I'll be able to see your attendance using the chat. Like I said, today people have been very lively. So I'm very sure today we'll have very good attendance. Also, I will also award everyone a point. I liked how lively the discussion today was. Today's discussion was good. Yeah, good. I think Odiro said something. Remember them. Yes, I do remember you saying something.